started in 1978, 9,000 square feet of poly greenhouses, my wife and I. And we had wooden benches, dirt floors, weren't really recycling anything back then. In 2002, we built our first flood floors. So at that point, we were really collecting all the water, batch treating it, and then recycling. And in 2005, I believe, or six, we put our first ozone system in. We were batch treating all the way up until then. And so we put in our first 120 gallon per minute system. And then in 2007, we started another big project, which now is 12 acres. And in 2008, put an ozone system in that. And that we included the UV system that I had abandoned in 2000. We have ozone, UV, and then a bactivator, which is a bacteria to help get rid of the chemicals out of the system. So that's pretty much where we are today. We have heated concrete floors. We're collecting the water. And you can see these floors, the water just goes into this crack in the middle, it's collected, goes to the end. The water, as gravity feeds back to these two tanks. Two options, one for clean water that we want to just keep reusing, the other one for water that might be contaminated with a chemical or some type of soil disease that we don't want to take a chance on. A grower will come in here and he'll just he'll just be going like this, feeling these spots, they're okay. And then maybe 2 o'clock this afternoon, come back and do the same thing, and you're just going by weight. What they're really checking, because one of the reasons they have the rows down the middle, there's a little bit of pitch to the floor, so this edge usually gets dry first, and so they might have to hand water the edges one time every once in a while. We have kind of really pure water. Our alkalinity is only like 10, and our pH is about 4.3. So it took a long time to finally get that working properly, but they've done a real good job on fertilizer. One of the negatives of ozone is it takes out iron and manganese, and in certain crops that's critical. So the chelated form that we use of iron is, and because our water pH is, it's kind of like the perfect storm. Between the water pH and the chelate, the type that we use, it's less effective. Take all that water, batch treat the tanks constantly, but then on the fly, as the water goes out, we'll be able to increase ozone levels to whatever we want. And so that all my pipes, we get rid of all the biofilm that's in the pipes, which clogs emitters and does other things in there. And hopefully we'll be able to give our plants more oxygen at soil root level.
When you flood a bay, like you guys saw out there, you got 5,000 gallons of water to flood that bay. And then anywhere from 500 to 800 gallons is being used up by the plants. The rest comes back here and just goes through the whole process again. But in this little block here, we're able to change the feed, change how much time we want to flood that day, soak time, or just how long the water will just sit there. Pretty much give us all the info we need for
that full control right there.
Full control right here.
So underneath of this entire area are tanks. We have 4 tanks that are about 28,000 gallons each. They're our flood tanks. It's also helped with the ozone part because we can tank treat one while we're using the other one, and then when that one starts to get down, we'll fill it up again and start using that one and switch treatment to the other one. So these pumps are drawing the water out of the tank and pumping it out to the greenhouse, and then the pump that's in the tank out there pumps it back, and it comes through this filter. And it's working right now, actually. That little silver thing in the middle, the little ball in the center,
yep.
As the paper gets dirty, the water will start to rise because it's not going through, and as soon as it pushes the ball up to a certain level, it moves the paper forward. So that's first level, comes back from the floor through there and into a tank. So then the gray lines that you see there go into this room. So we're filtered down to however many microns we are, I'm going to say 20. And then these are filled with glass beads. So this goes to 5 microns. The first 6. Then it goes from here to the actual ozone skid. The water is charged, and then it goes into this tank to mix, and that's where the kill takes place. And then every night these tanks have to be backwashed. And so you're backwashing, in this system, almost 2,000 gallons. And that's all the junk that's in the tanks. Well, that's the worst water that you have. We didn't know what to do with that. That was just going into the pond. And so we came up with this guy over here. So as we backwash now, we go into this tank, and then every night or every morning before they start, we run it through these two really fine bag filters, and we can really get a lot of junk out. And then we put the water back in the tank and reuse it. So now we have ozone, and our tank's being ozoned. And then when we have that water that we want, we might have chemical in, or it might have pythium or something in it that we want to clean. This is where he's gonna, how about you explain this process?
If we have a floor that has a disease in a pythium, we'll go ahead and we'll take that water and we'll put it to a trash tank. Out of that trash tank, we'll ozone that water to kill the pythium. But there could be like a chemical in it, like a drench that they use to kill that.
Bonsai or something.
Yeah, the bonsai drench. We take that out. We ozone it first, which will kill the pythium. It'll kill any other kind of pathogens and stuff in the water. We take the chemicals out. We run it through a UV light, which destroys that ozone, and it creates some kind of free radical spike in the water. When that takes place, the ozone's destroyed, and then we can go ahead and we can put it through we use bacteria. And what that does is they eat up all the chemicals in the water. We'll run that, and then we can take that water and pretty much clean water. The disease is killed in from the ozone, and then the chemicals are taken out from the biofilter.
I like the fact that there's no chemical additives. I mean, you're taking ozone, oxygen, electrically charging it to O3. It does its thing, and it goes back to O2 again. So it's like, this is pretty good. I like the idea of getting extra oxygen to my plant roots, and that's just a positive. The more oxygen's there, the better it is. We're adding oxygen. We're trying to get rid of chemical applications. If we don't have to fungicide as much because our roots are healthier. It was expensive, and you can see the numbers. I probably have $1 million in clean water right now. But when it's all said and done, we'll have a closed loop system, which nobody has. And we'll be using all of our resources as efficiently as possible. Less chemicals, less fertilizers, less everything. So it's pretty cool to be able to, at some point, say, nothing runs out of my greenhouses at all. Yeah.